Question 7. Lakshmi is asked to determine the limit as x tends to 0 of sine of 5x over x cos 5x. Show how she confirmed that it is acceptable to use L'Hopital's rule to find this limit. I remind you of L'Hopital's rule, which says the limit of f of x over g of x as x tends to k is equal to the limit of their derivatives. The one derivative over the other is x tends to k on one condition, and that is that the initial limit is indeterminate, 0 over 0 or infinity over infinity. There are other indeterminates as well, 0 to 0, etc., but we're not worrying about those here. So I need to substitute 0 into that and hope we get either 0 over 0 or infinity over infinity. So the limit as x tends to 0 of sine of 5x over x cos x is sine of 0 over 0 cos 0. Sine of 0 is 0, and 0 times anything is 0. So yes, it's indeterminate. So it's fine. Now we have to use L'Hopital's rule to find that limit. So we're going to differentiate the top and we're going to differentiate the bottom. Top line, that's a composite function, or in other words, it's chain rule. Sine of 5x goes to cos of 5x multiplied by the derivative of the inside function 5x, which is 5. Bottom line, x cos x, so that's a product. Derivative of the first, 1, times the second, cos, plus the first, x, times derivative of the second, minus sine x. And I'm going to substitute 0 in at this stage. If this ends up being indeterminate again, then what I'll do is I'll differentiate again. But let's check to see. 1 times 5, because cos of 0 is 1. 1 times cos of 0, 1 times 1, plus 1 times 0 times 0. So it ends up being 5, so there is our limit. It's given that y equals the square root of 4x plus squared plus 1. Show that dy by dx equals 4x over y. Well, this is a big hint to you already. That's probably a useful way to go, is that you're going to be able to use implicit differentiation. So let's take that and square both sides. There we are. So it's y squared, we drop the square root on that side. Now we can differentiate each term. Y squared differentiated is 2y, but that's the outside function. The inside function is y, because this is derivative with respect to x. So therefore we have to multiply by derivative of the inside function, dy by dx, or y prime, equals derivative of 8x squared, 4x squared is 8x, and the 1 goes. Divide by the 2y, and we already have our answer, dy by dx equals 4x over y. You can do it from there if you want to. So dy by dx equals half into 4x plus 1 to the minus half times 8x. So there are differentiated. This is 4x squared plus 1 to the half. So you multiply down half, subtract 1 off the top, so minus a half. The inside stays the same, and multiply by the derivative of the inside, 8x. That simplifies to half times 8x is 4x over the square root of 4x squared plus 1. And of course, 4x root 4x squared plus 1 is equal to y. Oh, we've got the same question again. Oh, no, we haven't. This is the next one. We're now doing the next part. Right, so we know dy by dx is 4xy to the minus 1. From there, now we have to show that d2y by dx squared is equal to that. So I have to differentiate the derivative. So we're going to use product rule. Derivative of 4x, 4 times y to the minus 1, plus 4x times derivative of y to the minus 1, minus y to the minus 2, and we have to multiply by the derivative of the inside function y, so it's dy by dx. Now, of course, we know what dy by dx is. That's quite useful, so we can substitute in here. See, there's your 4x over y. So there's 4y to the minus 1, 4 over y, 4x over y squared, and it's minus, and dy by dx is 4x over y. And that simplifies to what we're expected to show. Determine derivative with respect to x of ln x minus 4 over 4x minus 1 and simplify your answer. Well, derivative of ln is 1 over that. So it's 1 over that, and then we've got to multiply by the derivative of the inside function. So therefore we have 1 over x minus 4 over 4x minus 1. There's the derivative of ln of that. That goes to 1 over. This one, the inside function, we differentiate by product rule. Derivative of the top, 1 times the bottom, 4x minus 1, minus the top, x minus 4, times derivative of the bottom, 4, all over the denominator squared. Now this dividing here means we can invert it. So 1 over x minus 4 over 4x minus 1 becomes 4x minus 1 over x minus 4. We're simplifying this fraction. 4x minus 1 has cancelled into that 4x minus 1 squared. That's why we have a 4x minus 1 left. And we have x minus 4. And that simplifies to 15. We can do it another way. And logs are quite useful with that. We can separate this into a difference of logs. So we can say the derivative with respect to x of ln of that fraction is derivative with respect to x of ln x minus 4 minus ln 4x minus 1. Remember, ln a over b is ln a minus ln b. So now we can differentiate each of those separately. Both of those are composite functions needing chain rule. Ln of x minus 4, so we get 1 over x minus 4 times derivative of the inside, which is just 1. You don't have to show it, but I'll show it for you. Derivative of ln of 4x minus 1 is 1 over 4x1 times derivative of the inside, 4. Which, if we find a common denominator, we get the same answer. Seven 7.3.2. F of x is cos x and g of x is 2 over e to the 2x. Determine d by dx of f of g of x, giving the answer with positive exponents. Well, the first thing I'm going to do is to find f of gx, which means that g of x has to go inside f of x. So x must be replaced with whatever gx is equal to. So there we are. F of g of x is equal to, f's the outside function, so still cos, but instead of x we'll have 2 over e to the 2x or 2e to the minus 2x. Derivative now is equal to, well, the outside function is cos, so therefore minus sine the inside, leaving the inside exactly the same. Now we need to differentiate the inside function. And 2e to the anything comes back with that same thing, 2e to that something, but we have to multiply by the derivative of the inside function there. So we've got a function inside a function inside a function. Outside minus sine, leave inside the same. Now we're doing this one. Outside 2e to the summing, so it just stays 2e to the summing. That's the characteristic of derivatives of e to the x. and then derivative of minus 2x is minus 2. And there is our answer with positive exponents. Phew, quite a long question this. 7.4, the curve of y equals 2 ln 8 minus x beats the curve of y equals x at a single point x equals alpha. So there's y equals 2 ln 8 minus x. There is y equals x. Give the equation which will have to be solved to calculate the value of alpha. Well, that's pretty straightforward, hey, because it's the crossing over of two graphs, therefore it's the one that equals the other. 2 ln 8 minus x equals x. Y equals that, y equals that. So if they're both equal to y, they're equal to one another at that point. And I'm just going to write it like this because we're going to be going on to a Newton-Raphson method, and we need it equal to naught. So we have a function here. Show that 3 is less than alpha is less than 4. So alpha, so we must show that this value here is between 3 and 4. Well, the way to do that is to substitute 3 into one of the equations and substitute 4 into one of the equations and show that the one's positive and the other one's negative result. So it's above below the axis, and that it's continuous. So 2 ln 8 minus 3 x minus 3 is equal to 0.227 greater than 0, less than 0, and therefore it goes from greater than 0 to less than 0, and it is continuous. Now we have to use Newton's method to determine the value of alpha, correct to 5 decimal places, using 3,5 as the first approximation. Show full working for the calculation of the value of A. So there's the formula. A1 equals A0 minus f of A0 over f prime of A0. A pretty simple formula. It is in your information booklet. Now, let f of x equal 2 ln 8 minus x minus x. That's the equation we're solving. You see, it's that equals that, which means that that minus that equals 0. So we're solving that equation. You see, you need to remember that Newton's method finds the x-intercept of a curve. So now we're going to find f prime of x. So 2 times the derivative of ln 8 minus x is 1 over 8 minus x times a negative 1 for the inside function. That negative comes from derivative of 8 minus x. And minus 1 to differentiate x. So now we can go about that. A1 equals, now we're going to substitute 3,5 into the first case, because that's where we're starting. A0 is 3,5, and we're going to substitute 3,5 into the derivative. So there we are, substituting into the original function, substituting into the derivative, and it's A0 minus, so 3,5 minus. And that gives us 3,159,491 blah blah fish paste. Store that on your calculator, because while we are now we only need to 5 decimal places, we cannot approximate along the way. So you store that in the memory. Remember, it's just shift RCL because the store STO is above the RCL. So shift RCL and then the line just above, click on the button on the left that has a red uppercase A. We've stored it in memory bank A. Now we're going to repeat the procedure with this one. So A2 equals, and what happens is, it said show full working for A1, so I'm not showing full working for the rest. You don't need to. You could just go straight here, and you could just type in that again, where you're going to use recall memory where there's a 3, 5, and you get that answer. Store that in the memory, and I would store it in memory bank B in case I have to come back to that one. And then we put recall memory in again, and we end up with exactly the same answer. So that's fine. We now have a repeat of the answer. We're not going to get any more accurate than that to 5 decimal places. So therefore alpha equals 3,15563.